Hello, my fellow YouTubers. We're going to extend part 2 on my motor design. If this helps you guys out there at all. Right now, we're going to be using the same magnet off the Dremel. This time, we're using the same wire. This time, we're in the middle of a little PMH set up like this, to where coil, and the RotoZip magnet is in the middle of the two iron prongs. So basically, same setup and a similar except for the delivery is different. And I want to show you guys the difference on the increase in amperage and the voltage. And right now we have a resistor in, which is a brake light for a car, for a van. So it requires 12 volts, and I believe the last time I checked it, I'm pretty sure it said 2.1 amps, but it lights up here with almost a half an amp. So let's give it a whirl. Guys ready? Fire in a hole. You can see the magnet slowing down. You can see there's a big draw against the magnet. So let's go ahead and step it up. Stick it in. So take notice that the delivery between the relationship between the magnet, one side of this is positive, the other side is negative. So when you put it in there against the metal, it doesn't want to separate. And the same thing with the back side doesn't want to separate. So it creates a magnetic tension in between the iron and the magnet. So the key is to get it in there, have it separated by very, very little. So what we're working on, and I'll show you guys some of the techniques that I'm using on shielding. So if I could shield the gap between the magnet and the iron, which is inside here, or even this here also, then I'm able to, one is create less resistance, less drag, and produce the same amount of power. So over here is your amp meter, over here is your voltmeter. This is set to 50 volts. So you got to look, the DC right there. So it's coming up to around here. So it's around 30 something volts. And let's give it another whirl. Also, I guess we could take it and hook it up to this motor. So we'll take it off the battery and we'll connect it to the motor. And what we'll do is we'll see the motor turn in a different speed. You can tell that it's speeding up different. One-handed trick here, guys. So if you guys are at home building your motors, hopefully I can help you out through the process on some of the things that I notice, that the reaction between the iron and the magnetism helps you guys in design of your motors that you build. And you can have all different kinds of motors. Let's give this a whirl and see the spin. Alright, so you you can tell now it's really taken off. It's like supersonic speed. So it's going to be dancing as I move in and out. But check it out. We'll also get up here to the meters, okay? We'll see what's happening. The voltmeter is missing an apparatus. Thing's dancing around so much. I think that this is where she goes. Steady she blows. This is where she goes. Let's check it out. Ooh, that's on 50 volts and it made the voltmeter go nuts. Let's turn this up to 250. What the heck is going on there? You guys see that spike in volts? Alright, let's give it a whirl. So I hope you guys at home learning something here. So here with designing coils for around the wheel, I'm seeing what's better, and obviously I can't create anything off these spokes here, these magnets, that resembles this. I mean, the PMH would have to have something rotating inside of it in order for something, and maybe what we'll do is we'll build a big PMH to go around the whole wheel, and say if we take this and the front of this represents, what we'll do is we'll come down, we'll turn it back here, come back up, go past the side, and we'll put our coils here and here. All right, one big PMH, wheel turning, massive power. We'll have to hook it up to my breaker panel and run some stuff in my shop. All right, you guys. This is pretty cool stuff, man. It feels empowering to be able to make your own energy. Nothing. This is freshly made power from the St. Vincent Company. St. Vincent Motor Works. Buyout.